Have you ever wondered how machine learning algorithms work and which ones are most frequently used? Well, machine learning algorithms are the backbone of artificial intelligence, enabling computers to learn from and make decisions based on data. They are vital in a world that's increasingly data-driven. In this video, we'll unpack different categories of these algorithms, including supervised, unsupervised, reinforcement learning, and other notable algorithms. So, strap in for an enlightening journey into the world of machine learning. Let's dive right in and start with supervised learning algorithms. Supervised learning algorithms are designed to learn by example. First up, we have linear regression, an algorithm that predicts a continuous target variable by establishing a linear relationship between input features and the target. It's like predicting the temperature based on the month of the year. Next, we have logistic regression, which is a go-to for binary classification problems. It models the probability that a given input falls into a default class. Think of it as predicting if an email is spam or not. Then we move on to decision trees. These are tree-like models that make decisions by splitting the data according to certain criteria. It's like playing a game of 20 questions with your data. Random forests are an upgrade to decision trees. They create multiple trees and combine them to improve accuracy and control overfitting. It's like crowdsourcing decisions from multiple decision trees. Support vector machines, or SVMs, are powerful classifiers that separate different classes in the feature space by finding the best hyperplane. Picture it as finding the widest possible gap between classes of data. K-nearest neighbors, or KNN, is a simple algorithm that classifies data points based on their closest training examples in the feature space. It's like voting for a class based on who your neighbors are. Gradient boosting machines, or GBMs, are ensemble techniques that build models incrementally and combine their predictions. It's like learning from past mistakes to improve future performance. Finally, we have neural networks. These complex algorithms recognize patterns and are particularly effective for deep learning tasks involving images, text, and audio. Think of this as the brain of the machine learning world. Now that we have a grasp of supervised learning, let's move on to unsupervised learning algorithms. Unlike supervised learning, unsupervised learning algorithms are left on their own to discover and present the interesting structure in the data. Let's delve into some of these fascinating algorithms. First up, we have k-means clustering. This algorithm partitions data into distinct, non-overlapping subsets or clusters based on feature similarity. It's like organizing a messy drawer into neat compartments. Next is hierarchical clustering, which builds a hierarchy of clusters either by connecting individual clusters together or breaking down a large cluster into smaller ones. Imagine a family tree of data points. Then there's principal component analysis. This technique transforms data into a new coordinate system, maximizing variance and helping us identify the most significant features. Following this, we have T-distributed stochastic neighbor embedding. This is a technique for visualizing high-dimensional data by reducing it to 2 or 3 dimensions. Lastly, we have autoencoders, a type of neural network used to learn efficient encodings of data, often for the purposes of dimensionality reduction. After understanding unsupervised learning, let's look at reinforcement learning algorithms. Reinforcement learning takes a different approach, where an agent learns to behave in an environment by performing actions and seeing the results. Let's dive into some of the key reinforcement learning algorithms. First up is Q-learning. It's a value-based algorithm that learns the value of an action in a given state to maximize the reward. Imagine playing a video game where every move matters. Q-learning helps in deciding which move could lead to the highest score. Then there's deep Q networks, or DQN. It's like Q-learning but supercharged with deep neural networks. This allows agents to learn effective policies even in high-dimensional state spaces. Think of navigating a drone in real-world scenarios. DQN would be your go-to algorithm. Policy gradient methods, on the other hand, optimize the policy directly. They're like rule makers that define how an agent should act in a given situation. Now, let's talk about a few other notable algorithms. Naive Bayes, based on Bayes' theorem, is widely used for text classification tasks. It's like the Sherlock Holmes of algorithms, deducing class membership probabilities. hidden Markov models or HMMs model time series data and sequences. They're often applied in natural language processing and bioinformatics. Think of them as time travelers analyzing patterns from the past to predict the future. Lastly, ensemble methods like bagging and boosting combine the predictions of multiple models to improve overall performance. They're like the Avengers of algorithms, each bringing their strength to the table. This wraps up our quick tour of the most frequently used machine learning algorithms. As we've seen, machine learning is a vast field with a variety of algorithms. From the simplicity of linear regression to the complexity of neural networks and supervised learning, the partitioning power of k-means clustering in unsupervised learning, and the reward-maximizing approach of Q-learning in reinforcement learning, the range is truly impressive. Other notable algorithms like naive Bayes and ensemble methods only further underscore this diversity. Remember, the right algorithm to use depends on your specific needs and the nature of your data. Thanks for tuning in.